Hey guys, welcome to question 16. So, starting with part A, we have a square and the eigenplane has these vertices, you can see right here. And we have the complex numbers ZA, ZB, ZC lie on the square and form the vertices of an equilateral triangle. And we want to find the exact value of the complex number ZB. So ZB is up here, and we know this is an equilateral triangle. So, one thing we can take a look at first is we know the sort of at least imaginary components of our complex numbers, because as you can see, they lie on the square. So ZB, let's say it has an imaginary component of, well, let's say we can just rewrite it as m plus, alright, let's do it for part A, m plus 5i, since we know it lies on the top half of the square, and let's say ZC is equal to n plus 5i, since we know it lies on the bottom. So using these numbers, so it's right here as well, we can play around with the properties of complex numbers and just kind of see how it goes. So we know that this is an equilateral triangle, so the modulus of, or sort of the distance between all the points are equivalent, and we also know that they have an angle of, well, in an equilateral triangle, it's 60 degrees, which is, in other words, pi over 3 radians distance. So what I'm doing here is I know that this line can just be rotated pi over 3 radians counterclockwise to reach this line. So in other words, let's see, ZB minus ZC is equal to e to the I pi on 3. So when you rotate it, and no change to the length or the modulus, so e to the I pi on 3 times ZA minus ZC. So now we just rewrite both sides. ZB minus ZC is equal to, C M, oh crap, I rewrote that wrong. That is meant to be minus 5i. Sorry about that. It's 5i. So ZB minus ZC is just M minus N, the real part. Let's see, 5 minus negative 5 plus 10i is equal to e to the I pi on 3. It's just cos pi on 3, which is just half plus I sine pi on 3 is root 3 over 2 times ZA minus ZC. ZA is given by 5 minus N plus I times, let's see, 1 minus negative 5 is 6i. So plus 6i. Now let's just expand the right side. So that's just equal to half 5 minus n plus 3i plus, let's see, root 3 over 2, 5 minus n, I minus root, let's see, 6 times root 3 over 2 is 3 root 3. And then adding the real parts together, so that's half 5 minus n minus 3 root 3 plus I, imaginary parts together, 3 plus root 3 over 2, 5 minus n. Now we equate both sides together, so we know that m minus n is equal to real part, so half 5 minus n minus 3 root 3. And we know the imaginary parts are also equal, so 10 equals 3 plus root 3 over 2, 5 minus n. And then now we just solve them together. So using the, let's see, bottom equation first. So from equation 2, 7 equals root 3 root 2, 5 minus n. 5 minus n is equal to 14 over root 3. And n equals 5 minus 14 over root 3. So now we just pop that back into the first equation. so that's first one. So m minus 5 minus 14 over root 3 is equal to half of 5 minus n, which is going to be half of 14 over root 3, which is 7 over root 3, minus 3 root 3. Root 3. Rewriting that again, so m is equal to 7 root 3 minus 3 root 3 plus 5 minus 14 over root 3. Therefore, m is equivalent to, let's see, 5 minus, let's see, 7 over root 3 minus 3 root 3. So a little bit of a not very nice number, definitely. But if we simplify it down, that is just going to be around, it's times everything by root 3. 5 root 3 minus 7 minus 9 over root 3, which equals 5 root 3 minus 16 over root 3. Times by root 3 again, just to kind of get rid of everything. That's 15 minus 16 root 3 over 3. And therefore the exact value of the complex number ZB is just equal to 15 minus 16 root 3 all over 3 plus 5i. Since you remember, it's on the top half of the square. And that will be it for part A. So next for part B, we have a projectile of mass m kilograms is launched vertically upwards from a horizontal plane with initial speed v0, which is less than 100, blah blah blah. The projectile lands on the horizontal plane 7 seconds after launch, and find the value of v0 correct to 1 decimal place. So this one is a little bit tricky, but let's first get our equation out, which is force equals mass times acceleration, if you guys know. So we initially launch it up here, and then it comes back down 7 seconds later. So let's write it down. So mass times our acceleration, which is dv over dt, is equal to negative 0.1 m times v minus m times g. In other words, dv over dt equals negative 0.1 v minus g. So what I'm going to do is I'm just going to factorize out the negative and leave everything else as it is. So negative 0.1 v plus g. So bring it to the other side. So the integral of dv over 0.1 v plus g is equal to the integral of negative dt, which gives us over here of, let's see, 1 over 0.1 is just 10 times ln of the absolute of 0.1 v plus g is equal to negative t plus c, some constant. So how do we find it? Well, we're just going to find it by when initially t equals 0, we have velocity is equal to v0, as it says over here, initial speed. So we have 10 times ln 0.1 v0 plus g is equal to 0 plus c. Therefore, this entire thing is equal to c. So we have ln of absolute g 0.1 v 10 times that is equal to negative t plus 10 times ln absolute 0.1 v0 plus g. And let's just rearrange. So we have, let's see, let's bring t to, well, let's bring them both to one side and bring the 10 over. So ln absolute of g plus 0.1 v I'm going to bring the other one over. 0.1, g plus 0.1 v naught is equal to negative t over 10. Now the reason we're going to do this is just so we can get rid of everything, because we know that velocity is always going to be positive in this case. So we can just say that it's always going to be greater than 0. So it's equal to negative t over 10. So now let's let everything go up to the power of e. So g plus 0.1 v over g plus 0.1 v naught is equal to e to the negative t over 10. Then we times it up. So we have g plus 0.1 v is equal to g plus 0.1 v naught times e to the negative t over 10. And again, we want to let v be alone, so the 0.1 v is equal to negative g plus 0.1 v naught e to the negative t over 10. And then finally we can rewrite our velocity as 10 times this entire thing. 10 times negative g plus 0.1 v naught e to the negative t over 10. Now the reason we do this is because we know that v is just dx over dt. Let's let x be the distance between the two. So let's integrate both sides. So integral of dx is equal to the integral of 10 times this entire thing plus g plus 0.1 v naught e to the negative t over 10 dt. Therefore, that's going to give us x equals 10 times negative gt plus g plus 0.1 v naught e to the negative t over 10, all divided by negative 10. And this entire thing plus c again. So now we get our initial conditions. So when t equals 0, we know x is 0 because it's at the horizontal plane initially. So then we sub that all in. So 0 equals 10 times, let's see, 0 plus g plus 0.1 v naught. E to the 0 is just 1 over negative 10 is just times negative 10 plus c. Therefore, if you times it through, 0 equals negative 100 g plus 0.1 v naught plus c. And therefore c is equal to 100 g plus 0.1 v naught. Summing that all in, we get this really big equation of x is equal to 10 times negative gt minus 10 g plus 0.1 v naught e to the negative t over 10, negative t over 10, plus, let's add c down here, 100 g plus 0.1 v naught. Oh, and now finally, we can get to our final step, which is all our conditions at the end. So at the end, we know that at t equals 7, we have another x equals 0. And we also have the fact that, well, g equals 10. So we can sub in all our values in again. And finally, that leaves us with 0 equals 10 times c. So negative 70 minus 10 times 10 plus 0.1 v naught e to the negative 0.7 plus 100 times 10 plus 0.1 v naught, which again simplifies down to negative 700 minus 100, let's see, 10 plus 0.1 v naught e to the negative 0.7 plus 100, 10 plus 0.1 v naught, and then we'll bring 700 over to the other side, equals 100 times 10 plus 0.1 v naught. And we can actually factorize out the 10 plus 0.1 v naught. So that gave us with 1 minus e to the negative 0.7. As you can see, you can factorize these. And then we rearrange, so we get, let's see, 7 equals 10 plus 0.1 v naught times 1 minus e to the negative 0.7. So we know 10 plus 0.1 v naught is equal to 7 over 1 minus e to the negative 0.7. V naught is equal to 0.1 v naught is equal to 7 over 1 minus e to the negative 0.7 minus 10. And finally, v naught is equal to 10 times this entire thing. 10 times 7 over 1 minus e to the negative 0.7 minus 10. And if you times this all together, v naught is going to be equal to 39.05 blah blah blah, which rounds up to v naught equals 39.1 meters per second, correct to 1 decimal place. A very long, a very challenging, and very tough question. If you managed to make this far, good job for getting through. And that will be it for part B. Next, for part C, we have, it is given that for positive numbers, blah, 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 with arithmetic mean A, we have that, and we do not need to prove this result. So, going into the question, suppose a rectangular prism has dimensions A, B, C, and surface area S. First part, show that ABC is less than or equal to S over 6 to the power of 3 over 2. So, using part C, let's get our rectangle up first. So we know it's a rectangle with, let's see, dimensions, let's say A, B, and C. So the surface area is going to be given by 2 times AB, which is this surface, plus 2 times BC, which is this surface, plus 2 times AC, which is this surface. And we can simplify that down to S equals 2 times AB plus BC plus AC. Next, we want to use our arithmetic sort of mean thing. So letting our sort of numbers be AB, BC, and AC, we have the arithmetic mean of them is equal to AB plus BC plus AC all over 3. And therefore, we can sort of use the result that, how about A squared, B squared, C squared? So this is just AB times BC times AC is going to be less than or equal to, this thing is less than or equal to, the arithmetic mean to the power of 3. So the arithmetic mean is here. So arithmetic mean is AB plus BC plus AC over 3 to the power of 3. And here's what we know. That's just equal to S over, let's see, so if S is equal to 2 times that, then that's just equal to S over 6 to the power of 3. Alright? So we have A, B, C all squared less than or equal to S over 6. That's an S to the power of 3. Finally, we can rewrite this inequality as ABC is less than or equal to S over 6 to the power of 3 over 2. And that will be part I. So next for part II, we have, using part I, show that when the rectangular prism with surface area S is a cube, it has maximum volume. So first off, we want to know what is the volume. The volume of a rectangular prism is just going to be given by ABC. And look what we have here. we have our inequality. So we know the volume is less than or equal to s over 6 to the power of 3 over 2. Therefore, the upper bound, or like sort of upper limit of volume, so max volume when equal. So we know that the maximum the volume can take is when it's equivalent to s over 6 to the power of 3 over 2. So if a cube, then a equals b equals c, since all sides are equal. So we'll let the volume just be equal to a times a, which is just a cubed. Surface area is a squared plus a squared plus a squared times 2. So 2 times a squared is going to be 6a squared. So that's the surface area. And finally, let's have surface area over 6 to the power of 3 over 2. So 6a squared over 6 to the power of 3 over 2 is just equal to a squared to the power of 3 over 2, which is a cubed. It's volume. So hence maximum volume when it is a cube. And that will be it for part C. Next, for part D, we have find all the complex numbers z1, z2, z3 that satisfy the following three conditions simultaneously. So modulus of z1, z2, z3 are all equal. We have z1 plus z2 plus z3 is equal to 1. And finally, z1 times z2 times z3 is also equal to 1. So first off, we know that since mod z1, z1, z2, z3 is equal to 1, and we have that modulus of z1 equals modulus of z2 equals modulus of z3. So when we times them together, the modulus of z1, z2, and z3 should also equal 1. And therefore, they all have a modulus of 1. So all the moduli will be equivalent to 1. So because of that, you guys should hopefully remember that when you have a complex number, when you have its sort of reciprocal, that is equal to its conjugate if the modulus is equivalent to 1. So using that idea, we can kind of rearrange the third equation here. So z1, z2, z3 is equal to 1. So using that, that is not a 2. We can write z1, z2 is equal to 1 over z3, which is just z3 conjugate. And same thing with the rest. So z2, z3 is equal to 1 over z1, which is z1 conjugate. And finally, z1, z3 is equal to 1 over z2, which is the conjugate of z2. Since remember, they all have a modulus of 1. So finally, if you add them all together, that's just going to be z1, z2 plus z1, z3 plus z2, z3 is equal to the conjugate of z1 plus conjugate of z2 plus conjugate of z3. And if you remember your conjugate rules, that's the same if you just conjugated the whole thing here. Oh, whoops. Finally, if you guys can see on the left-hand side, well, the conjugate of that is just going to be 1, because conjugate of 1 is just 1 anyway. So this entire thing is equivalent to 1. So now hopefully you guys can see what we're doing here is this looks awfully familiar to sums and products of roots, right? So we have sum of roots, so z1 plus z2 z3 equals 1. We have the sum of the pairs of the roots, 1. And finally, we have the product of the roots, right? So if you guys remember, this should have, these three numbers should be the solution of the polynomial equation of z3, z cubed minus z squared plus z minus 1 equals 0. So using a sum and product of roots, we can kind of reverse engineer the polynomial equation from it. And the cool thing is, well, this is a really easy polynomial to solve. So let's factorize out as z squared plus z minus 1 equals 0. That's z squared plus 1 times z minus 1 equals 0. And finally, into its complex roots, z plus 1, z minus 1 times z minus 1, z minus I, and z minus 1 is equal to 0. Finally, the three numbers that solve are when z1, z2, z3 are the numbers 1, I, and negative I. That will be it for part D of question 16 and the 2022 extension to HSC paper. So congratulations for making it to the end, and I will see you guys next time.